Hello everyone, a very good evening. Right, so let us get started. So yesterday we have discussed about the hypothesis testing, and also we have seen how we can conduct this hypothesis testing in Python. Right. So today we are going to discuss about a new concept called scatter plot and the correlation coefficient. So let us discuss, and because we are going to use these two concepts, so scatter plot and correlation coefficient. So in regression analysis, so that is what our next topic is, right? Okay. First, let us start with the scatter plot. So scatter plot, also known as scatter chart or scatter graph. Excuse me. Right. So this uses the dots to represent the values for two different numerical variables. So especially the scatter plot will be used to find out the relationship between the two numerical variables. First of all, let us understand what are the variables. What do you mean by variable? So I have collected the data. Let us say, for example, the age of the employees. Okay, so this is employee name. So this is a name 1, name 2, like this. The age we have collected 28, 25, 40, like this. Then also I've collected one more information, that is experience. So let us say this is 5 years, this is 3 years, this is 15 years, like that we have collected the experience. And what is this column called? This is called as variable. And this column is called as variable. That means we have two variables here. So this is a variable 1 and this is a variable 2. Two variables. Now, if you want to find out so how these two variables are related, the relationship between the two variables, then we can go for a scatter plot. So first of all, as we discussed, what are the variables? So this column is called as a variable. This column is called as another variable. And if at all, if you want to find out the relationship between the two variables, numerical variables, you can go for scatter plot. Okay. Now, so coming to the relationship, what do you mean by relationship between the variables? What kind of relationship does exist between the variables? Let us understand that as well. So any variable, any two variables, let's say x1 and x2. So this is, you can understand, you can think of this as the age and this is the experience. So any of the two variables, the relationship could be positive, the relationship could be negative, or there is no relationship at all. No relationship at all, right? So this also possible. That means, so if you find out the relationship between the two variables, so it could be positive relationship, negative relationship, or no relationship at all. Now we are interested to find out, so the variables share what kind of relationship, a positive or negative or no relationship. That is what we want to find out, so that we can identify. So using this scatter plot. Now let us see how we can do that. So for example, I have a variable temperature. So this is a variable 1, and this is another variable ice cream sales. Right? So the temperature here we have 14.2 degrees, 16.4 degrees, like that, and we have ice cream sales. Now let me mark these data points so in a two-dimensional space. So this is x-axis and this is y-axis. Okay? And then I'll take each and every data point, I'll mark here. Let us say the data point 14.2 and 215. So 14.2 is here somewhere and 215 is somewhere over here. So this is the data point. So this data point, the y value, ice cream sales, and y-axis we have the sales. So how much it is? 215. And the temperature is 14.2. 14 point. Okay, so this is the data point. Now let me mark some other data point. Let's say, for example, if you see this data point, so around 18 is the temperature, and then the sales are around 400, for example, right? And this one, so 16, right? So 16.4, this is the data point, and 325. So this is 325, 16.4. So that means, so this is the data point you can see here, this one, and here. So 25 is a temperature and the sales are little above 600. Let us make it as 600. Now these are the data points. So just we have taken this data, the two data point, the two values. So we have represented with one dot. So one is on x-axis, the other one is y-axis. Right. Now we are talking about the relationship. What kind of relationship that we are talking about? So what is happening if you observe this? So the temperature values so are increasing, right? So 14.2 to 16.4, 18, 25. So when these temperatures are increasing, what is happening with these sales of ice creams? Are they increasing or decreasing? They're also increasing, right? So 215, 325, 400, 600. That means as the temperature increases, the sales also increasing. So that is called as positive relationship, positive association. So positive association, right? Okay. Now, so here, one more thing we need to understand. Out of these two variables, we will call one variable is a dependent variable. The other variable is called as independent variable. One is dependent and independent. Okay. So dependent variable is, so this variable will be affected by the other variable. And independent means, so this does not get affected by any other variable. So out of these two variables, so what do you think? The temperature depends on ice cream sales or ice cream sales depends on temperature? Obviously, the ice cream sales depends on the temperature, right? It's not the other way around. That means the temperature does not affected by the ice cream and ice cream sales will be affected by the temperature. So this dependent on the temperature. So the temperature is affecting the ice cream sales. That means this is independent variable and this is dependent variable. Now, so the independent variable always denoted by X. The ice cream sales, this is a dependent variable. This will be denoted by Y. And now here if you see, so the Y variable would go to the Y axis. The X variable would go to the X axis. So that's how. So we will identify the X axis, the variable and Y axis variable. Now here I can see the values as the temperature increases, the independent variable increases, the dependent variable is also increasing. That is what you see the positive slope. As these values are increasing, these values also increasing. That is what the positive slope. And that means so the temperature and the sales share positive relationship. Okay? So that is what we can understand. So from this scatter plot. Now let us discuss about the negative association. Right. So now let us discuss about the negative association. So that is, we have again two variables. One is the cigarette smoking habit in years. So this is the lung capacity. Okay. And what you observe here? So as the number of years of cigarette smoking is increases, so what is happening with the lung capacity? Lung capacity is decreasing. So 0, 45, 5, 42, 10, 33. Right? So that we can clearly evident here in this plot. As the X is nothing but the cigarette smoking habit and Y is lung capacity. Okay, lung capacity. And this is 0 years, the lung capacity is 45, and this 5 years, 42, 10 years, 33, 15, 31, 20, 29. Right? So if you see the number of years increases, what is happening with the lung capacity? Lung capacity is going down. So the slope is negative slope, the data points. That means as X increases, the Y is decreasing. So this kind of association is called as negative. So negative association. Okay, negative association or negative relationship. Right. So this also we can identify from the scatter plot. Okay. So this is fine. So we are saying that hey, so as X increases, Y increases, or X increases, Y decreases. So that association is good for us. But I want to find out, I want to quantify the strength of the association. So how much actually it is increasing or decreasing? If I increase X, so how much Y is going to decrease? Or if I say that, hey, these two are a positive relationship or these two are in negative relationship. But can we say that, hey, these two are strongly positively related, or these two are strongly negatively associated? So can we quantify the strength of the association? Yes, we can quantify that. We can give a number, right? So I can give a number to that. Hey, these two are so negative 0.8. Then people would understand. Okay, negative 0.8 is a good, the negative association. Here also I can say that, hey, this is a positive association. I'll say that, hey, 0.9. So positive 0.9 is the association between these two variables. Then people understand that, hey, this is a very good association, right? So that means I want to quantify the association using a concept called correlation. Okay? Correlation coefficient with with small r. Okay. So what is the correlation coefficient? Let us understand this. The correlation coefficient or correlation analysis is a bivariate analysis that measures the strength of linear association between the two variables. So here also we'll have the two variables. One is variable 1, variable 2. These are independent and dependent variable, or whatever it is. So it measures the strength of linear association between the two variables, and it gives us the direction also, the direction of the relationship. Okay? So when you compute the correlation coefficient for any of the two variables, always the correlation coefficient lies between -1 to +1. That means whatever the value that you get out of this correlation coefficient, okay, correlation coefficient, always the value lies between -1 to +1. So it can take any value between -1 to +1. That means, so this is a normalized the quantity. Now, how do we interpret these values? I have a variable, let's say for example, x1 and x2. Okay. So when I compute the correlation between these two values, two variables, so I have got a correlation 0. So what does that mean? So that means, so there is a low to no linear association or no correlation between the two variables. And as you move away from the 0 to the right side, positive side, or to the left side, negative side, as you are moving away from this 0, that means the correlation is increasing. So if it is positive side, the positive correlation. If it is a negative side, we'll call that as a negative correlation. If the correlation coefficient is -1, then this is called as high correlation, but it is a negative correlation. So if it is a positive one, then that is also called as high correlation, but this is a positive correlation, right? So these are the three things we have to understand. The correlation coefficient range is -1 to +1. Okay. And if the correlation coefficient is 0, that means there is no linear association between the two variables. So always the values are between -1 to +1. And how do you compute the correlation coefficient? The correlation coefficient you can compute using this formula, right? So R is nothing but the correlation coefficient. We'll use this formula to compute the correlation coefficient between the two variables, and we'll get these values. Then, so let us interpret the correlation coefficient. So how do we interpret based on the values? So we can interpret using this the graded interpretation. Let's say, for example, if the values are 0.1 to 0.3, then you can say that is a weak correlation. The values are 0.4 to 0.7, then you can say that is a moderate correlation, and 0.8 to 0.1 is a strong correlation. So even so this graded interpretation holds true or good for the negative values also. If the value is -0.1 to -0.3, or -0.4 to -0.7, -0.8 to -1.0. Okay. So still you can say these are weak correlation, negative correlation, these are moderate, and this is strong correlation. Right. Now let us understand pictorially. So visually, so what is this correlation coefficient all about? So if you see here, this is the variable x, independent variable, and this is a y variable, a dependent variable. And if you use the scatter plot between these two variables, and if you happen to see the data points forms exactly the straight line like this. All the data points are on the straight line. This indicates high correlation. First of all, the data points forms a straight line. So this indicates very high correlation. And if it is going up, the line is going up, that is called as positive correlation. And how much is the correlation value? That is 1, positive 1. And then here we have X and Y. For example, I'll give you one more example for this. Hours of study, number of hours of study, okay, marks. So this gives you the positive correlation. So if you increase number of hours of study, let's say 10 hours, okay, 15 hours, 30 hours, 50 hours like this, okay, the marks also would increase. Yeah, the marks also would increase. So marks, let's say here 35, 50, okay, so 80, 90 like this. The marks also would increase. That means, so these two are in positive association. May not be perfectly positive, but so this kind of a line are the positive data points will get it here. Then here the negative association. So the line is going down, right? So as X increases, the Y is decreasing. And all the data points are forming exactly a straight line, right? So this association is basically a negative association. The correlation is perfectly negative, highly correlated. Right? And if you see this one, yeah, this exactly suits this example. So if the data points are not forming perfect straight line, but overall trend is positive trend. Yeah, the overall trend is positive trend, and you can see here the data points are here and here like this. And this is a positive correlation, and correlation may not be exactly one, but this is the moderately high correlated the data points are the variables. You can see these data points, these variables, hours of study and number of marks a student gets. Right? So these are positively correlated variables. Now coming to this one. This is a negative correlation as the trend is going down. So the trend is a negative 0.7. The correlation value is negative 0.7. Right? And here the example we can think of a number of hours so are getting wasted in social media. Okay, like let's say number of hours wasted in the Facebook, for example, and marks a student gets. Right, so number of hours a student is wasting on the social media during study hours, and number of marks a student gets. Right, so these two definitely so inversely proportional. So more hours study hours are getting wasted, so the marks are going to be low. And if you see the association between these two, you can see this kind of association. So as the hours are increased, the wasted hours are increased, the number of marks are going to be reduced. So this is a negative association, that is a negative 0.7. And here we have one more image where there is no definite pattern, right? So there is no increasing trend or there is no decreasing trend. All the data points are randomly distributed in the plot. So in this case, what is the correlation? The correlation, especially the linear correlation, is 0. The linear correlation is 0, right? So that means so the X is not affecting Y linearly. That is what the linear correlation means. Right? So let me quickly give you the recap. We have discussed about positive correlation, where X increases, Y also increases. Second one, negative correlation, where X increases, Y decreases. Third one is no correlation. That means so no association. Where X increases, Y doesn't increase. Right? So there is no association between these two parameters. So these are important. Positive, negative, and no correlation. Right. So here you can see these are perfect positive correlation. All the data points forms a straight line. And here a little bit scattered. The data points are scattered here and there, right? And this the trend is also positive, but the data points are not forming straight line exactly, but the positive trend is there. So that is where we can see the high positive correlation here, 0.8. And here we have the scatteredness is more, but there is a little bit positive trend. So that is where you can see 0.4 is a correlation, positive correlation. And there is no linear association because the data points are randomly scattered, 0 correlation. And this is going down. This is a negative 0.4, negative 0.4. That is the negative correlation. Okay? These are negative correlation but high correlation, and this is perfect correlation. That is a negative correlation. So that's how actually based on pictures, images of the scatter plots, you can roughly estimate how much is a correlation or strength of the association between the parameters, right? And one more important point about the correlation coefficient is correlation coefficient does not depend on the slope of the line, right? So if you see here, so the slope is like this. So there's a positive one, and slope decreased. But still, this is a positive one. Slope further decreased. Still, this is a positive one. And so here also, here and here. And if you see a line like this, so for this, the correlation coefficient is not defined. So remember this. So the correlation coefficient for this horizontal line is not defined. Right. Now, all this while we are talking about the correlation coefficient gives us linear association. Yeah, linear association or linear relationship. Does it mean the non-linear relationship do exist? Yes, of course. So there are non-linear relationships also. So how do they look like? You see this? This is a non-linear relationship. This is a non-linear relationship. This also. All these diagrams shows non-linear relationship. Okay? Now, so here if you want to find out the association between the x and y for this kind of a shape where the non-linear association, for that we'll get the correlation coefficient is equal to 0. Because the correlation coefficient always gives you the linear association. It doesn't talk about the non-linear association. So that you have to remember. You should not argue that. So if you get the correlation coefficient is 0, that if you say that hey, there is no association at all, the x is not affecting y at all, so that is wrong. Only you can say that hey, there is no linear association between the two parameters. That means the correlation coefficient gives you only the linear association. Remember why I'm stressing upon this is, so a lot of people would assume that if they find the correlation coefficient is 0 means they are not at all related, and x is not affecting y at all, and they'll throw it away that variable. Okay, so that is wrong. So that means there are non-linear relationships do exist, and those have to be identified with appropriate tools. The correlation coefficient doesn't give you the information about the non-linear, only gives you linear association. So for us, the scope of the discussion is only linear association. That is what we are interested in. All right. Now let us use both of these techniques, scatter plot and correlation analysis, and let us see how we can solve a use case, a business case. Let's say, for example, I want to investigate the smoking habit and lung capacity, and whether these two are related. So, if they are related, what kind of relationship exists, and how much the strength of the relationship exists between these two variables. Let us understand that now. So, investigate the relationship between cigarette smoking and lung capacity. So, the data is the sample group response data on smoking habits, measured lung capacities respectively. That is what the data here you can see. The cigarettes, the lung capacity. So, the number of years of cigarette smoking habit and the lung capacity. The lung capacity is basically so how much the quantity of air so that your lungs can hold. So when you inhale, so how much amount of air quantity so can be withheld by the lungs. Okay, so that is what the lung capacity. As the number of years of smoking habit increases, the lung capacity is decreasing. That is what you can see here. It's clearly evident that the as smoking years increases, the capacity is going down. That means what kind of association is there between smoking and lung capacity? Is it a positive or negative? Please post your comments in the chat window. Yeah, please post your what kind of association you can see here. It's a positive or negative. So it's a negative because as x increases, y is decreasing, right? So this is a negative association. That's correct. Right. And you can see here the correlation coefficient. Okay. So the correlation coefficient here is a negative 0.96. So if you compute these two, right, the correlation coefficient minus 0.96. So that indicates, so there is a high negative association so between these two variables. As the number of years of smoking habit increases, then the lung capacity is going to be certainly so diminishes, decreases. So the lung capacity is going to be decreased. So that's how actually we can apply these two concepts and we can understand the lung capacity, the correlation and the scatter plots, right? All right. Now we are going to discuss about the linear regression. Okay, so for that we need these two concepts, the correlation and scatter plots, right? So just give me a minute. Right. So just give me a minute. Let me open the other one. Oh, okay. There is a question. I missed it. What is the correlation coefficient for vertical line? So that also not defined. So because if you see the formula, okay, right. So if you see the formula, so if x is not changing, okay. So when you get a vertical line you will get like this, right? So this is x. For same x value, y is changing. Okay. So that means so x is here, y is here. So x is 2. Let's say for example 2, 2, 2, 2, 2, 2. Okay. And this is 5, 3. It is increasing, right? Let's say for example uh, 3, 5, okay, 7, 9, 10, like that. That means for the same value of 2, the y is increasing. That's where you will get the vertical line. Now, if you apply here, so that means x minus x bar. Okay. So, so the average of this, what is average of this? 2. And if you compute x minus, so 2 minus, okay, 2. So this is nothing but 0. Summation of all these things would be 0. 0 into some value here would be 0. That means the denominator is going to be 0. Even for vertical line or horizontal line, the value, the correlation coefficient is not defined, right? Okay. All right. Okay, so now let us discuss about the linear regression. Okay, so these are the learning goals. So what is a regression? Why the regression? So where are we going to apply this regression? We are going to discuss a few use cases, scatter plot. Anyway, we have already discussed, and we have discussed about the correlation coefficient, because these two are very important concepts we are going to use in the linear regression, and also we will use this in various other statistical analysis as well. And then we discuss about the simple linear regression. Okay, so then fitting the regression line. These are the learning goals. So we are going to learn. So regression analysis. So if you want to predict a future performance of a business parameter, we'll have to combine a concept of correlation and regression analysis. When you combine concept of the correlation plus regression analysis, then we will get the ability to predict a future performance of a business parameter. Okay. Now, so what is the linear regression equation? Okay, the form of the linear regression. The form of the linear regression equation is this. So y is equal to beta naught plus beta 1 x. Okay. Let me give you the idea of what are these things. Okay. So do not get scared. So when you see this equation, so because we are going to do a postmortem, we are going to do so a lot of analysis on this equation, and we are going to dispel. So what is what all these the terminals all about? So y is nothing but the dependent variable. Beta naught is the intercept, y intercept. Okay, beta 1. So a beta 1 is a coefficient of r, the slope. You can say this is slope. So x is nothing but independent variable. Right. So these are the terminologies that are there here. So that is y equal to beta naught plus beta 1 x is called as the regression equation. That is simple linear regression equation, and this is epsilon is the error. Right. Now, for example, so I have a used car. So I want to find out how much the cost of the used car. So based on one parameter. So I have the number of kilometers, for example. So based on this number of kilometers, so I want to find out so how much is the price of the car. Then how can I do that? Yes, use this regression equation. Like, so I have the price is a y variable, because I want to find out this price. This is y variable based on what? Based on kilometers. Kilometers affects the price, and it is not other way around. Price does not affect the kilometer. Kilometers, as more number of kilometers, then the price would go down. That means the age of the car increases, right? Yeah. So that's the idea. So price is a y variable, and then beta naught plus beta 1 into kilometers, so plus epsilon naught. So this is my regression equation, right? And here, so yeah, the same thing. Used car cost is equal to beta naught or beta 1 plus beta 2 into miles driven, kilometers, plus error. So this is a regression equation. So if you want to use, so for a practical application like this. Okay, fine. Now let us discuss about one example here. So we have here experience and salary. Two variables we have. So what do you think? Which one affects the other variable? Does experience affects the salary, or salary affects the experience? What do you think, guys? Obviously, right? So that means, so experience affects the salary. As experience increases, in general, salary also increases. That means the experience is X variable, the salary is Y variable. So this is a dependent variable, and it depends on the experience, and experience is affecting the salary. Now, if you see in the scatter plot, this X and here is a Y, experience, and Y is salary. And so if you see this, what kind of association, so you can observe here, is it a positive or negative? Yes, it is a positive. As experience increases, the salary also increases. As you see here, the positive curve. That means the correlation between these two parameters must be positive. Must be positive, right? Yeah. So this we understand. Now the question here is, imagine that you are running, okay, you are running a consultancy, okay, a professional consultancy, and you're offering your services to the professionals to find out the right package for their years of experience. Let us say there is a person. Okay, so this person so is into IT industry for 5 years of experience for 5 years. Now this person wanted to shift or move his company, shift his company. Okay, move to a different company. Now this person wanted to understand. So what is the best package so that he or she can code with the potential employees. So currently, let's say this guy is getting 10 lakhs per annum. So with his experience or with her experience in the industry, so the other people, how much they are getting and what is the best package so that this guy can get? Is it 15 lakhs or is it 20 lakhs or 50 lakhs or 10 lakhs? So how much so this guy can get? So that is what actually this person wanted to know, right? That means, so you being you as a professional, the consultant, right? So you are expert in that services, okay? And that person approached you. So with the 5 years of experience, and this person wanted to know what is the right the salary for this guy. So that is what you are trying to find out. Okay. Now you are a data scientist, let's say. So you have collected the past details or the people who have placed who are doing the job currently in the industry, their experience levels as well as their salary you have collected. So a 2 years of experience guy, so that guy is getting 50K US dollars. The person who has 4 years of experience, that guy is getting 70K US dollars. Like that, you have collected this data from the industry. Now what you have done is, so simply you have used this scatter plot, all the data points here we have experience, and this is salary. All right. And so just you have marked all these the data points in the scatter plot. Then what we want to find out, I want to find out 5 years of experience. So how much that person should get. Now just drop a line here. These are 5 years. So just drop a line exactly to 5 years from this line. Okay. So this line, you see this dotted line, you can think of this is a representative of all the data points. So this data, this line is a representative line of all these data points. And from these 5, you can just have a line. You can drop a line onto this dotted line. And from here, where these two lines are intersecting, dotted lines, so have one more line onto the y-axis. And here, let's say, for example, this 65K, this is 65. That means a person who has 5 years of experience, so that person should get around 65K US dollars. Now you can answer this question, this person query. Hey, so you have 5 years of experience, and this is the industry data. On an average, so you should get 65K based on your experience. So that's how we can answer the questions based on the analysis, and this analysis is called as regression analysis. Regression analysis, right? So this is similar to the real life application. Let me show you. Right. So this is a Stack Overflow. The same thing, whatever we have done. So this using this site, so you can find out. So based on the location, based on the experience, based on the domain and technical skills, so one can identify so how much that person should get, okay, in the industry. So I'm posting this in the comment section. So you can also just play around this. Right. So select role close to yours. Let me select data scientist, right? And lives in Mumbai. Education, let me select a bachelor degree, for example, years of experience. Let me select 5 years of experience. So technology, I'll go for Python. Now let us calculate salary. Yes. Now you can see here a 5 years of experience guy, the 50th percentile, that means the median. So recall the discussion that we had, the descriptive statistics, the 50th percentile, that is nothing but the median and an average. So 9,80,000, so they are getting. And 75th percentile, at loose sense, you can think of probably the maximum salary. So not even maximum, little lower than the maximum you can think of. So 15.8 lakhs. So 25th percentile, 6 lakhs. Okay, so that is the salary range. So on average, a data scientist who is doing the job, who is living in Mumbai, 5 years of experience, who has a bachelor degree, working in a Python, can get 9,80,000, right? And this is what actually exactly we have done. Now, if you see how this estimation has been done, we can learn more about their methodology. Let us click on that. They also have given some other insights, probably can go through that. So median salary for different types of developers. So these are the other the technologies, probably you can also have a look at it. Right, so building a model to estimate the salary. So they have used multiple linear regression equation. So whatever we are going to discuss, so that is what they have used in the website. So to predict the salary, so based on the different parameters, right? Yes. Okay. Now let us go back to our the discussion here. We're talking about 5 years of experience person, how much this person should get, and we have solved that question using this diagram. Okay, 5 years here, and then just we have uh, dropped a line onto the y-axis. These are 65k, and we said that 65k is the right the package this person should get. Right, that is fine. So we have solved the problem. But what is this line called? This dotted line. So this dotted line is called as regression line. Okay, regression line. So how do we represent this regression line in a mathematics or mathematical way? So this regression line, so we can write it like this. So y equal to mx plus c. Okay, so little math we are going to discuss. Yeah. So y equal to mx plus c. What is this mx plus c? Y equal to mx plus c. As we know, y is y-axis, so the dependent variable. So x is independent variable, and the m is nothing but the slope of the regression equation. So c is nothing but the intercept, y-intercept. What is that? What is the y-intercept? So if you see here, this line is going like this, then the height at which actually the regression line is intersecting the y-axis, so this is called as y-intercept. Y-intercept or c here. Then the slope of the regression line is this. The slope is here. All right. So now we know these terminologies, and as we discussed, the regression line is y equal to beta naught plus beta 1 x. So the same thing, whatever we have written here. So these are y equal to mx plus this is what actually we've been studying a line equation. So from 10th standard, right? Now this is a different notation in the statistics. We are going to use this. So if you see the terms, if you map the same thing actually. So here also y equal to c plus mx. So the c is nothing but the beta naught and m is nothing but beta 1, x is x. So that means, so beta naught is a intercept, beta 1 is slope of the regression equation. And henceforth, we are going to use this terminology. Okay, so this equation we are going to use for regression equations. Now, so here, this is a phi, let me write it down again. And dependent variable is salary, independent variable, experience. Now my regression equation is y equal to beta naught plus beta 1 x, right? And so this is y variable and this x variable. Let us plug this into this regression equation. So y is salary equal to beta naught plus beta 1. Beta 1 into x. X is what? Experience. Experience. Right? Now, so for this new data point, this new guy, We know what is experience value. Let us plug this value into the equation. So salary is equal to beta naught plus beta 1 into 5. So in order to find out the salary for a 5 years of experience guy, what do I need to know? I need to know beta naught and I need to know beta 1. So from where we'll get this? So from this data set, we are going to estimate. And for example, let us assume that. So if we extend this, so this line is touching around 30, for example, and the slope of this regression line is 4. Okay, or 5. Okay, let us go for 5, 6. Okay. Let us go for the slope is 6 and C is 30 or beta naught is 30 here and M is 6. Okay. Now we are going to plug these values also into this equation. Now salary is equal to beta naught. Beta naught is nothing but the intercept plus beta 1. Beta 1 is nothing but the slope of the regression equation. That is 6 into the 5 here. So 30 plus 30, that is 60. That means a person has 5 years of experience, so that person should get 60K US dollars. So that is how we can use the regression equation to predict for a business parameter or a future data point. Now, you might get a question, hey, how did we get this 30 and how did we get this 6? This we'll discuss after the break. So here in this case, I've just assumed that. So the C intercept is beta naught is a 30 and the slope is 6. But we'll discuss that. And that methodology is called as least squares method. So least squares method. So using this method, we are going to estimate. So what are the value? The values for the beta naught and beta 1. That we'll discuss after the break. Let us take a break now, a 10 minutes break. Yeah. All right. Yeah, hello all. Let's continue our discussion. Now let us understand the linear regression using a business case. Okay. So the business case here is a newspaper. Okay, the data set we are going to discuss. Yeah, the business problem here. So is to investigate the feasibility of starting a Sunday edition for a large metropolitan newspaper. And for that, the information was obtained from a sample of 34 newspapers concerning their daily and Sunday circulations. Okay. So the problem here is, so imagine that so you are running a newspaper agency, okay, a newspaper company. Let's say your company is A. Now your company so is into daily editions. That means you are circulating, your company is circulating the newspapers daily. Okay. Now your management has thought, so why don't we start a new edition so that can be circulated on Sundays. So this is what actually we want to start. Okay. Sunday editions. So we see, right. So generally in the railway stations, there are a lot of tabloids, right? Sunday magazines, right? So this is what actually your company wanted to get into. Now, so before getting into the Sunday edition, before setting up infrastructure and everything, they want to estimate if they get into Sunday edition, okay, if they launch the Sunday edition, how many number of people would buy it? So that is most important, right? If there are no customers, there is no point in launching the Sunday edition. They want to estimate how many number of customers would buy. So if you launch the Sunday edition, that is what they want to estimate. Estimate. So how many Sunday editions can be sold? So this is what actually I'm trying to answer. All right. So for this purpose, so what you have done is, as a data scientist, so you have collected the data of your competitors, 34 newspapers. So in that area, let's say you are living in Mumbai area, for example, okay, and you have collected the 34 newspapers so that are being circulated in the Mumbai region. So that is Baltimore Sun, Boston Globe, Boston Herald, like that. So you have collected 34 newspapers, their daily circulations as well as Sunday circulations. Because so you are into daily business, okay, so daily editions you are circulating, and you want to get into the Sunday editions. So that means daily information you need, Sunday information also you need. Similar to that, you have collected the daily and Sunday information of your competitors' data in the region. Now using this data, so I want to estimate, so how many Sunday editions can be sold. Now this is the classical problem of regression. And if you recall the discussion that we had, so based on experience, how much salary, right? So if experience increases, salary increases. That means if I want to find out the salary, I need the experience. Here also, if you want to find out the Sunday, you need daily details. That means I can build a regression equation like this. Y is equal to beta naught plus beta 1 x plus epsilon. Now what we want to estimate? I want to estimate, okay, estimate Sunday editions. Yeah, Sunday editions. So based on what? Based on I have one piece of information with me based on daily. Right. Now the Sunday is depending on, it is based on daily. So that means Sunday is a different variable and daily is independent variable. Now let's plug this into the equation. Sunday equal to, okay, beta naught plus beta 1 into x. What is x? X is daily. So plus epsilon. So epsilon anyway. So we cannot remove this error from the regression equation. So you cannot also use this. Yeah. So just ignore this error. And now my regression equation is this. So Sunday equal to beta naught plus beta 1 into daily. Right now, since you are running company, newspaper company, and you said so you are into already the daily business, daily editions. You are circulating daily editions, and so how many number of daily newspapers you are circulating, right? So you can get that from business. And let's imagine that you are circulating daily 200,000 newspapers. So that is what your the sales on daily basis. Now, so for 2000 sales, 200,000 sales beta 1, I want to estimate Sunday circulations. If my company is selling 200K, 200,000 or 2 lakhs daily circulations I'm selling, what would be my Sunday circulations? So this is what actually I'm trying to answer. Hope this is clear to you all. Now, to calculate this, so what I need to know, these are the parameters here now. The beta naught is a parameter, beta 1 is a parameter. I want to find out these two things. So as we discussed in earlier example, what is this beta naught and beta 1? So if this is a regression line, this is beta naught, the intercept, and this is the slope of the regression line beta 1. Using this data, so I can estimate this beta naught and I can estimate this beta 1, right? The slope of the regression line and the intercept of the regression line. And simply I can estimate these things using the least squares method, and we're going to discuss that now. And then simply I can, once I get those values, just plug in the values in the regression equation, then you are good to go, right? So just simply you can evaluate the numerical, the calculation, and you will get the Sunday circulations. So this is the whole objective that we are going to do now, right? Let me show you the data set details as well, so that you'll get an idea here. So the data set here is just a minute. So this is a data set we are going to use. Let me show you this. All right. So this is a newspaper name, and this is a daily circulation. So of this newspaper, 391K, it means 391,000. Okay. And Sunday circulations 488K. And these are the total 34 data points we have, 34 newspapers details we have collected. And using these, we are going to build the regression equation. Okay, fine. So the first step in building the regression equation is to find out the association between the parameters. So you can see the association, the daily circulations and the Sunday circulations, the data points are like this. So what kind of association you see here? Is it a positive association or negative association, or there is no association at all? A quick response. So what kind of association you see here, guys? Right. So that's a positive association, right? So this is a positive association we can see here, right? Great. So that means, so as a company's daily circulations are increasing, you can expect the Sunday circulations also is going to be increased. So that is what the positive association means. And from this data, so if a company's daily circulations are more and Sunday circulations also will be more, that is what actually, so the diagram describes here, right? Okay, this will skip here. And as I mentioned, so how are we going to find out the regression line? Okay, regression line, the intercept, that is beta naught, and the slope of the regression line, that is a beta 1. So we will use a method called least squares method. So what is the least squares method is, the concept of the least square method is this. So let's say this is a regression equation and these are the data points. So X and Y. So what we do is, we will find the difference or the distance between the data points to the line and to the line. So this is the perpendicular distance. Okay. So all these distances. So let me call this as D1. Okay. So this is D2. This is D3. So like that, find out the distances from all the data points to the regression line. Now, so we'll take all these things. Okay, so D1 square. Okay, I'll square that. What is the distance that we have? So then D2 square plus D3 square plus so and so plus Dn square. So then we will find out so beta naught and beta 1 for which values of beta naught beta 1. So this error is minimized. The square of this is nothing but the error only, right? So the D1, that means, so this is my regression line and this data point, nothing but the original data from the data set. The distance between the prediction and the original data is called as error. Okay, error, how do you define error? So error is yi minus yi hat. We'll discuss more in future. So this is the y value from the data set and this is a predicted value from the regression equation. Okay, right. So the distance between the data point and the predicted the value, that is a regression line, so is called as error. And we'll collect all these errors and square it up. And so this is my error now. So for which values beta naught beta 1, this error is minimized. So that is called as the best beta naught beta 1 best fit line. And this methodology is called as LSM or least squares method. And using this least squares method, we could estimate beta naught and beta 1. And the formulas for that is, so these are the formulas we are going to use to estimate the beta naught, beta 1 and beta naught. Right? So using this, we are going to estimate. And my regression equation is as we discussed. This is my regression equation. So Sunday equal to beta naught plus beta 1 into daily. Right. Fine. Just imagine that we have estimated a beta naught and beta 1 using those formulas. And my regression equation is ready. We are going to see in Python how we are going to do that. But for the timing, just assume that, yes, my regression equation is ready. So beta naught plus beta 1 into, what is that, daily. So once you build the regression equation, is that end of the job? So can we just go ahead and use the regression equation? No. So we cannot and we should not. Because once you build the regression equation, you also have to find out whether this regression equation is a good regression equation or so this cannot be used based on the accuracy of the regression equation. So it is similar to a software. Right? So when you once you build the software, so directly are you going to productionize? Are you going to use that in the production environment? No, right? So the software has to be tested. There are a lot of testing phases like unit testing, system testing, integration testing, and all these things. A lot of testing would happen before we move into the production environment. Similar to that, so once you build the regression equation, this has to be validated. This regression equation has to be validated. And that validation is nothing but the accuracy of the algorithm. So how do you find out the accuracy of the algorithm? So for that, we have a measure called coefficient of determination R square. So this measure will use R square. So using this, we will interpret whether the regression equation is a good regression equation or it's not a good regression equation. So how do you find out this R square? So R square will find out using this formula, explained variation by total variation. Then what is this explained variation? So that is nothing but sum of squares of regressor by total sum of squares of total, and R square value is always between 0 to 1. Okay, so R square value is 0 to 1 for any regression equation. Let's say, so regression equation 1, the R square value is 0.9. Then I'd say this is excellent, very good regression equation. We have a great interpretation. If the R square value is less than or equal to point, let's say 0.6. So this is a very bad and average kind of a regression equation. So I would not recommend to use this regression equation. And if the value is, let's say for example, less than okay, 0.75. So this is a good regression equation. These are general, the thumb rule kind of thing. Okay, and it changes based on the domain to domain. And if it is less than or equal to 0.85, okay, so this is a very good regression equation. And if it is okay, so more than 0.9, then I would say this is excellent. So this is around 0.85 like that. So then this is excellent. That means if the Ascar value is less than 0.6, less than 0.5, then that regression equation is not going to be useful for us. If the Ascar value is near to 1, then that regression equation is very good equation. So as how much high, the better the regression equation. If it is low, below 0.5, then that is not at all so useful for us for the prediction of the business parameter. All right. Now, so we said that this is SSR and SST. What are these SSR and SST? First, let me give you the idea here. What are these YI, Y bar, XI, X bar? I have a data X. You can think of this is age, R experience, as we discussed, experience, and this is Y, and you can think of this is salary. So age, experience 5 years. Okay, this is 50K. 6 years, 70K, like that we have the values. 8 years, 100K, like that. So this is called as YI, the original data that we have. You see this YI, right? Then what is YI, Y bar? Y bar is nothing but the average of Y. Just take the average, that is Y bar. Then there is something called as YI hat. You see the cap, this is called as YI hat. What is this YI hat? The YI hat is the predicted value using the regression equation. Okay, YI hat. So predicted value using a regression equation. Right. So let's say, for example, so I have used my regression equation to predict for, so what is the salary for 5 years of experience guy. So as we have done just now, right? So let's say I have got 65. And for 6 years of experience guy, I have got, let's say, 60. And 8 years of experience guy, I have got, let's say, 100. Now, something called as error. Error or epsilon. How do you find out this? The difference between the original Y minus the predicted Y. That means 50 minus 65. That is minus 15. This is the error. 70 minus 60. That is 10. 100 minus 100. That is 0. And these are all nothing but the errors are nothing but the distances that we have seen, right? Just now we discussed. Okay, that what is the distance between this to this? The distance between here to here. The distance. So this is my original data point, and this is the predicted value using the regression equation. This is YI hat, and these data points are nothing but YIs. The distance between from here to here, so that is what the difference you see here, minus 15, 10, and 0. That means this data point is exactly on the line. So that is where you can see the difference is 0 for 100. And this is called as error. And this is SSE, error sum of squares. Now, so one more important thing here is, as we discussed, Y bar is average. So let's say this this y bar we have computed as 50. Then what is this term yi minus y bar? Yi minus y bar is this. From each of these data point, subtract y bar. 50 minus 50, 70 minus 50, okay, 100 minus 50. So this is a term. So just do that for all the data points, then sum it up. Then you will get SST. And similarly, SSR. Now subtract the y bar from this y hat or all the data points, sum it up, then you will get SSR. Then your R square value is nothing but SSR by SST. That means the sum of squares of regression by sum of squares of total. And this is basically called as explained variation. In simple terminology, so how much variation that is being explained by your X independent variables in the variation of Y variable. So that is what the R square value is. Okay. So R square value is between 0 to 1. So if it is very near to 1, then you can say that is a very good equation. If it is 0 to near to 0, that is a very bad equation. Based on that, we can find out the accuracy of the algorithm. Right. Now let us do this in Python. All right. So this is a Google Colab that we have been working, right? Right. Now let me show you how we can implement this linear regression equation, and then how we can use this linear regression equation to predict for a new data point. So load the data set. So pd dot read underscore csv, the data set name. All right. And some information about the data set. So let me load the data set here. You can see the newspaper name, daily and Sunday. So just we have printed here first five observations. Then information about the data set here. So newspaper, daily, Sunday. So this is the first column. There are 3 columns in the data set, right? And there are 34 observations. Then correlation. Find out the correlation between the data points, between the variables. Sorry, between the variables. Find out the correlation. So daily versus Sunday, how much is the correlation? 0.95. So is it a good correlation, high correlation, or is it a low correlation? So what do you think? Yes. So this is a high correlation, right? So because the correlation coefficient ranges from -1 to +1, and the correlation is, so if it is positive near to +1 or near to -1, then that is a high correlation. So here it is a positive, then we can say this is a highly positively correlated. These two variables are highly positively correlated. Fine. Now let us see the distribution plot. Yes, so this is the distribution plot for daily variable. And what do you observe here? So is it symmetrical distribution? No, there is skewness. So this is what actually see the skew. That means the values are there to the right side of the main distribution. Here, right skewed distribution. Fine. Let us see for the Sunday also. Yeah, here also the same distribution, right? So the skew distribution is there. Fine. Now let us go for the linear regression. The linear regression here is like this. So SMF, this is the library that you have to import stats models dot pharma dot API as SMF, alias name is SMF. Then SMF dot SMF dot OLS ordinary least squares. Okay, so this is also called as ordinary least squares method. And then y variable name. What is the y variable here in our question? Example, Sunday is a y variable, and daily is x variable, right? So this is a y variable. So daily is x variable. Then data set is data dot fit. Fit means so fit the regression equation. So once you execute this, then a model will be built. Yeah, these are a regression line that you can see. Then, so first of all, why we are doing this? So if you forget the business objective, let me recall. Okay, let me discuss that once again. I want to find out so how many number of Sunday editions we can sell. That is what I want to find out, right? So with that, we have built a regression equation like this. So beta naught plus beta 1 into daily. And so from company, so I can find out what is the daily value. That's what we said. So daily we are selling how many? 200K. So these are the daily the newspapers. So we are selling. Simply I can plug here. So that is beta naught, beta 1 into 200. So in order to calculate the Sunday editions, how many number of editions that we can sell. So what do I need to know now? So I need to know beta naught and beta 1. Then where do we get this beta naught, beta 1? Using OLS method, ordinary least squares method that we have seen the formulas. Remember, so beta 1 and beta naught, we have seen the formulas. Those formulas will give us this beta naught, beta 1. Okay. So do we have to manually compute? No, you don't have to do that. So that's where actually we are using Python to compute this beta naught, beta 1. So that is what you can see here, model parameters, right? You see model parameters. So intercept is so 13.83. Daily is 1.338. So just plug those values here. So 13.3. So 13.83. So that is the intercept. This is a beta naught value, and this is beta 1 value, right? So 1.34 into 200. Yeah. So this is the Sunday editions. Once we evaluate this, then I'll get that value. Let me let me calculate this. So 13.84 plus 1.34, 1.34 into 200. So from where we have got 200, so we are running our company, right? So we can get to know that value. So from the business, we can ask the business, hey, how many number of newspapers we are selling on daily basis? They'll give us this number. So this is 281K. That means, so if your company is selling on daily basis 200K newspapers, then you can expect if you launch the Sunday edition, so then you can expect to sell 281K Sunday magazines. So if this number is fine for your company management, so then they can start the Sunday unit. Okay, otherwise, so they have to see other alternatives so how they can increase the business. So this is how we can estimate the Sunday, and this is how we can solve the business problems. Okay, fine. Right. So a few more things this we'll discuss tomorrow. But before that, I would like to touch upon few things. So how to find out the R-square value? We discussed, right, R-square value and these things. So R-square value for this regression equation is 91. So 0.91 or 91%. That means, yeah. So that means this is a very good regression equation, isn't it? So if it is very near to 1, then that is a very good regression equation, right? Okay. Okay, so there's a question, when do we say that our model is overfit, underfit? So this we'll discuss when we discuss about the machine learning. Okay? So that is a very good question. We'll discuss that in the machine learning. Okay. Now, so do we have to manually compute the predictions? No, you don't have to manually compute the predictions. You can also directly use Python to compute that. Okay? So what we can do is, let's say for example, this is what I want to predict. For 200, okay, so daily sales, I want to predict. So pd.series 200. So create a series. So as we have created yesterday series data structure, then create a data frame. Yeah. Now you see in the data frame, so we have the values. Yeah. This is my 200, right? So this is what actually our daily circulation. Now I want to find out. So for this, how many number of Sunday editions we are going to sell. So model, this is a model is nothing but the model that we have built here. You see, yeah, this is a model object, right? So we have built and we have saved that model. So in this model object, now we are calling this model object model dot predict. Predict means for this 200, how many number of the Sunday editions, and data underscore predict. So this data is nothing but whatever the data set that we have prepared. So in this data set, what is there? 200. Just predict. So 281. So that is what we have got. That means you don't have to manually compute that. So directly you can use this predict method to get the y value for a given x input values. Okay. Now I want to predict for some more values like this 300, okay, 250. So I want to predict for this. So in the daily we have 200, 300, 250, whatever we have. Okay, so just input for each of these values. So we have got the Sunday magazine. Let's say imagine that you have 3 branches. So one branch is selling 200, second branch is selling 300, third branch is selling 250. The branch that sells 200 daily circulations, you can expect the branch can sell 281k Sunday circulations, and likewise 450, 415, 348. So this is how you can implement the linear regression equation, a simple linear regression equation in Python. Okay, fine. Okay, so there is a question here. So how intercept is 13.83? So the intercept is 13.83. So when the intercept becomes 200. No, 200 is not intercept. Okay, 200 is the independent variable. Okay, independent variable value. It's not intercept. Yeah. Right. And few more things. So we have to analyze. So as regression, as part of regression output. So when you get the regression, so you will get the intercept. So this is a beta naught. So this is estimated value of the beta naught from the data set. and this is the coefficient of the daily. So if you see the regression equation, y equal to beta naught plus beta 1 into x. Okay, so that y is nothing but, so Sunday equal to beta naught plus beta 1 into daily, right? So this is what actually the regression equation is. Now beta naught is nothing but the intercept, so that is a value of 13.83, and you see here coefficients of daily. What is the coefficient of daily? The coefficient of daily is nothing but beta 1. That is what actually here you see. So the coefficient of daily is 1.33, and there is something called as t value and there is something called as p value. What are these values? Okay, just a minute. Yeah. So what are these values? T value and the probability value. The t value is nothing but the same t that we have computed in the hypothesis testing. Recall yesterday's discussion. Okay. So t. So in case of one sample t test, all right. So x bar minus mu by, so s by square root of n. So that is same t value that we have got here. So 0.386, 18.935, and the p values we have got here, and the p value this is 0.7, and this is 2e minus 16. This is almost is equal to 0. That means the Python or R, whatever the tool that you are going to use, internally conducting hypothesis testing, and it is checking the p-value for each and every variable or coefficient. What is the purpose of that? So the purpose of this is to identify or to understand whether this variable, daily variable, is significant or not. So just remember this: if this p-value, okay, if p-value is less than 0.05, so then the variable is significant. Right. The variable is significant if the p-value is less than or equal to 0.05. So you can ignore this intercept. So even if it is less than or greater than, so you have to consider, just ignore this. You don't have to consider this. So what are the variable that you see here? Daily variable. What is the p-value? This p-value is almost 0. That means, so which is less than 0.05. Now this variable is significant. What do you mean by significant variable? Significant means, so when you are trying to predict or estimate the Sunday the value, whether the daily is going to be useful for you or not. That is what the significance means. See, let's say for example, I have chosen one more variable. The variable called in that area temperature I have chosen. Okay, Sunday circulation. Okay, so this is Sunday circulation. So temperature. Okay, so in that area, for example. This is a newspaper one, for example, and their Sunday circulations in that area exactly precisely what is the temperature, and second, third, like this. Now, do you think the temperature are really useful in predicting Sunday circulations? Temperature in that area? No, not useful. So to identify whether this variable is really useful for us to predicting this or not, this p-value we are going to use. If this p-value is less than 0.05, so that means we are going to reject null hypothesis, and we are saying that hey, the variable is significant. Okay, that's all. So we are going to use this the p-values in the regression analysis. So once you build the regression analysis, you are going to get the p-values for each and every variable, and then you can use this the p-value to identify whether the variable is significant or not. If the variable is not significant, so there are various reasons why the variable is not significant. Because of the outliers in the data set, because of the influences in the data set, because of the skewed distribution of the data, all these so things, so that we have to check, and then we can decide whether to include the variable in the data set or not, or in the regression or not. Yeah, that is the final conclusion. So this is how you can build the regression equation, and you can use the regression equation for the prediction of new data point. Okay. All right. Okay. So any questions? Okay. So all right then. So that's what I would like to cover for today, and we'll one of the session for today. And tomorrow we are going to discuss about a multiple linear regression equation. Okay, so that we'll discuss tomorrow. Okay, all right. So thank you. So thanks for joining, and we'll meet tomorrow. Bye for now. Yes, so we'll share the code as well as the data sets detail in the Google Drive. There's a question that's correct. So if the relationship between the variables are linear, then we can use this linear regression. Correct.